Okay, starting out with trigonometry, and I think this one's a little shorter than the other one. We're going to talk about kind of some of the stuff that led into the vector information we talked about today. So if I want to find the angle of the least positive measure and the negative angle that's closest to the and coterminal to the angle given at 402 degrees. So again, remember that if I were to go all the way around, if I'm looking at this, all the way around once is going to be, the other recording's done, is going to be 360 degrees. Oh, and I wrote it too. 360 degrees, right? So I know that 402 is bigger than that. I've gone around more than once, so I kept going, all right? And I stopped somewhere in the middle of the circle here. I'm trying to think about where. Okay, my brain's not working on it. So let's take a look. So I'm going to take 402. I'm going to take off the 360 degrees because I know that 360 just took me around the circle once. All right. So if I have 402 minus my 360, what I'm going to come up with is 42 degrees. So that right there is my least positive measure. It's between 0 and 360, and that's really what I'm looking for. So that's my least positive measure. If I'm looking at the negative angle that's coterminal to it, so basically what I have is, let's go down to this page. All right, what I have there is I went around the circle once, and then I kept going up to about here, and yeah, it's probably about 42 degrees right there. So this was my angle. This was 402 degrees is the dark purple. I can take this and I can say this is 42 degrees right here. Okay, so that's that angle. If I want to know my negative angle, okay, so that I'm going, basically I'm going backwards around. I'm saying, okay, so what's this angle right here? All right, so what I'm doing is starting at 360, I'm going all the way back to 42. So what I'm going to do is I'm going to say 360 minus 42, and that's going to be equal to negative 3. Oops, let's do that the other way. I'm starting at 42. I'm taking off 360. Let's do it the other way. So I have 42 minus 360, and that's going to be equal to a negative 318 degrees. So that's going to be my second angle there, right? So come down that way to see this one. This is my negative, okay? Very, pretty cool. Now, if I want to assume that theta is an angle, so I'm going to cordon this off just so we don't get confused. The next example, I want to assume theta is an angle in standard position. That means that I'm starting right here and going around the circle to wherever I stop, okay? So again, I start right here on this axis, the positive x-axis, and I'm measuring to wherever it is. In standard position, it has a terminal side that contains the point 2, negative 6, and I want to find the exact values of the 6 trig functions. So let's look at what we're looking at here. I'm going to draw my axes. I have 2, 1, 2, there's 2, and just move this one down a bit, maybe make it straight. And negative 6, 1, 2, 3, 4, 5, 6, negative 6. So I know that the angle is somewhere down here, right? So here's the cool part, is that I also know, if I look at this, let's find a color that's different. If I start to make a triangle, what I want is, I want the whole angle. I want this. In order to find, well, I don't. I want the trig functions, so never mind. What I want is the trig functions for this angle. It's going to be the same as the trig functions for this angle. This is, I'll label it theta 2. This is theta 1. Okay, those two trig functions, the trig functions for those two angles are the same because it's in the same place the angle is. Okay. What I do know is that if I zoom in here, what I do know is that the side of the triangle over here is equal to negative 6 on this side, like from here to here. I also know that from here to here, right, That's equal to 2. So now I kind of have a triangle. So let's draw our triangle a little bit. I'm wanting to find this theta. I know this is 2, and I know this is 6. Now I can use SOHCAHTOA, right? We can also use it using x's and y's, so I'll go over both. If I'm looking for this hypotenuse side, this last side over here, I know that I can say, let's label it z, okay? I can say that z is equal to the square root of 2 squared plus 6 squared. You could have flipped the order on those. That's going to be equal to the square root of 4 plus 36. So that's equal to the square root of 40, right? And I can reduce that a bit. That's, let's see, 2. So I would have, let's see, a 2 square root of 10, based on how we reduce things, all right? So this equals 2 square root of 10, all right? So that's what I'm looking at there. Now, if I want to use those, we have a couple options. I can use the SOHCAHTOA like I said, or I can say sine is, oops, let's write a theta in there. Theta is equal to my y over, in this case, my z. Your book calls it r, so let's make it an r, okay? Yeah, I'll make it an r everywhere. Oh, hold on. I got it. Okay, let's make it an r. R and r, since your book calls it r. Sine equals y over r. Alternatively, I can say sine equals opposite over hypotenuse, if you like it that way. So here I'm going to say that's equal to 6 over 2 square root of 10. Here I need to rationalize, so Pearson won't take anything if I don't. So I'm going to say square root of 10 over 10 is what I'm going to multiply by, that same thing that's over there, and then I promise I'll drop the red then. So I'm going to have 6 square root of 10 over a 2 times a 10, right? So that's a 20 there in the denominator. I'm going to divide by a 3, so I'm going to, or by a 2, so I'm going to get a 3 square root of 10 over a 10, right? So that's the value of my sine, right? If I look at cosine, I'm going to change colors because I hate red. Cosine theta is equal to my x value over r. Keep the positive or negative. Oh, this should have been negative. Let's go back. So this was a negative 6. This is a negative, and this is a negative. So pop the negatives on there, okay? Kill that. There we go. There. It's a negative 3 over, or square root of 10 over 10. You know, can't have that without a negative. All right. So x over r, if I look at x, I'm a positive 2 over my square root of 10, right? Again, I'm going to multiply by my square root of 10 over square root of 10 to rationalize. I get 2 square root of 10 over 10. This one's easier to reduce. I get a square root of 10 over 5. That's my value of my cosine function. All right. The next one, tangent, you have a couple ways to do it. Tangent theta is equal to my y over my x. If you wanted to do cosine, you could also do adjacent over hypotenuse. Adjacent over hypotenuse there. Okay. This is also equal to opposite over adjacent, depending on whether you like the triangle or you like the x and the y. So my opposite is, let's put the negative on it here. My opposite is negative 6 over a 2 is my adjacent or my x. So here I get a negative 3. That one looks a lot prettier and I don't have to do anything. Now, here's the fun part. If I look at the other 3 functions, they're all reciprocals of this one. It's like 1 over sine. So I tend to find sine, cosine, and tangent, and then I just flip them because I don't have to refigure it out when I do the others. So if I look at cosecant, let's change colors. Here, I'll do this color. Cosecant theta, that's the same as 1 over sine theta. So if I flip the sine theta, and I'm going to grab I'm going to grab this one right here. Okay, before I did any rationalizing. Otherwise, I'm going to have to reduce again because I'm going to have another. If I flip the one that's over here, I'm going to have to rationalize again, and then I'm going to cancel out tens, and I don't want to do that. So I'm going to start with the first one that I wrote down before I rationalized. So I'm going to say that this is equal to 2 square root of 10 over 6, and it's negative. I can reduce it. I'm going to say that's equal to negative square root of 10 over 3. Alrighty, so that's my first one. My next one, if I look at it, if you would rather do this, if you're just going straight on, you can do this. This is r over y, okay? If I look at secant theta, secant and cosecant are kind of weird because they don't seem to match. It's equal to 1 over cosine theta, all right? So again, I'm going to grab my earliest one. So let's grab this 2 over square root of 10 that I have over here. So I'm going to say it's square root of 10 over 2. There's not much I can do there, all right? So I'm all done already, all right? All good. Okay, so let's see. Last one is cotangent of theta. That's 1 over tangent theta. And that's going to be just a flipping of that. So I'm going to get a negative 1/3. I actually went off the answer there. So I actually pulled that from my reduced form over here, from right up here. Okay, to get that. All right. Hopefully that helps with those. There is one problem like that. If we look at the quadrants, we talked a little bit today about the quadrants. Quadrant 1 right here on this side, all of my trig functions are positive there, okay? And I'll get a positive x and a positive y. In quadrant 2, I'm looking between 90 and 180 degrees. My x values, you can see, are negative because I went over this direction. My y values, though, are still positive up here. So I have negative x, so my cosine and secant are negative. My y values are positive, so my sine and cosecant are positive. My tangent and cotangent, though, are both negative, all right? If you look at quadrant 3, I'm over here in this edge, somewhere in this range. Both x and y are negative, so all cosine, secant, sine, and cosecant are negative, and then tangent and cotangent are positive since they're the ratio of the x and the y, so the negatives cancel out. Quadrant 4 is over here between 270 and 360. Here my x is positive. I went this direction, and then I went negative with my y. So my cosine and secant are positive, my sine and cosecant are negative, and so are my tangent and cotangent. All right. So if I look at my sines of secant of 228, let's figure out where 228 is. If I put an angle on there, I'm past 180, but not up to 270, so I'm somewhere over here. I'm going to say this angle right here is 228 degrees. So I know if I'm looking for secant, I'm going to come right up here. Let's make it yellow. I can see that secant there in that third quadrant, because I'm in Q3, is negative. So I'm going to say for secant 228 is negative. All right. If I'm looking at cotangent of 163, let's draw another thing. 163 is between my 180 and my 90, so I'm somewhere over here. This is 163 degrees, right? So that means if I'm looking at cotangent, this puts me into Q2. This one, by the way, put me into Q3. Cotangent of 163 degrees. If we go and we look at Q2, we can see that cotangent, let's make it a green, oops, wrong one, green, cotangent there's negative, so cotangent's also negative, is negative, all right. The next one's I determine what quadrant I'm in based on where the terminal side is given the conditions. I know that cosecant is greater than 0. So that means that I know that my y value is positive. All right, so that means just off of this, I know I'm either in Q1 or Q2. All right, so I just write it down. If you want to go back to this, you can. Let's erase these real quick. If you want to go back to this, I'm going to go up here. I'm going to say, okay, I want a cosecant that's positive, so cosecant's positive here, and everything's positive up here, right? Only in two of them. Tangent, though, is less than 0, so I'm looking for a negative tangent, and what I see is that happens right here. So, and it also happens over here. Okay, so cotangent's negative in Q2 and in Q4. The only thing that I see that's in common here is Q2, so I must be in Q2 in the second quadrant. Okay, that's how we do it and how we look at it. We're just doing process of elimination there. Here, next one, we want to determine what quadrant or quadrants I'm in if the terminal side of the angle, or what the, let's read it. For the given value, determine the quadrant or quadrants in which the terminal side of the angle lies if I have tangent is equal to 4.400. So what I know here is that tangent is greater than 0, right? Tangent theta is greater than 0 because it's 4.4. So let's go back to our little chart up here. I'm going to erase all of these that I did there. All right, so we'll pick a different color. How about the blue? So if I know that tangent is greater than 0, what I see is all trig functions are positive here. So quadrant 1's a possibility. And then the other place where I see that tangent's positive is over here in Q3. Okay, so quadrant, I'm either in quadrant 1 or quadrant 3. So if I remember the one on the homework problem that's like that, it has a bubble. So you bubble in, you bubble pick all the quadrants it could possibly be in, right? I believe that's the end. Yeah, it's the end. All right, so that's the end of it. 17 minutes. Sorry, I tried my best, but I didn't want to talk so fast you couldn't hear me. So that should do it, and that's the end of the algebra and trig review, and I hope it helped. Good luck on the homework, and let me know if you have any questions. Bye-bye.